On a humid beach in the Caribbean, vervet monkeys wait for tourists to leave their drinks unguarded. In the dense forests of Guinea, wild chimpanzees fold leaves into crude sponges, dipping them into the naturally fermented sap of raffia palms. They drink until they stumble. It is a strange, unsettling thing to watch an animal willingly ingest a neurotoxin. But it is even stranger to realize that human brains are uniquely hardwired to do exactly the same thing. We are chemically rewarded for poisoning ourselves. This biological compulsion is not a modern moral failing. It is a hijacked, ancient calorie detection system. We are haunted by evolutionary ghosts. Modern humans willingly, systematically, and socially ingest ethanol. It is a volatile, flammable, psychoactive poison. We drink it to the point of motor impairment, cognitive decline, memory blackout, and severe physical sickness. A massive global industry is built around this ritual. We use it to soothe the pervasive anxiety of the sober mind and to ease the deep discomfort of modern socializing. We rely on liquid courage to initiate mating rituals. For many, it becomes a fatal, compulsive dependency that destroys bodies and families. In nature, consuming a toxin that impairs your balance and slows your reaction time is a death sentence. An inebriated animal is a dead animal. Evolution ruthlessly culls the clumsy and the slow. Yet, when humans consume this poison, our brains do not trigger a panic response. Instead, they trigger a massive release of dopamine, serotonin, and endorphins. In a safe, modern environment where calories are abundant and apex predators are gone, this biological compulsion to alter our consciousness seems entirely irrational. It looks like a self-destructive bug in the human operating system. But to understand this paradox, we have to look backward. We have to travel back to the late Miocene epoch, roughly 10 million years ago. The Earth was experiencing a drastic climatic shift. The lush, unbroken canopies of the African forests were drying up. They fractured into open savannas and scattered woodlands. For our arboreal, fruit-eating ancestors, this was an apocalyptic bottleneck. Food became agonizingly scarce. To survive, early hominids were forced out of the safety of the trees and onto the dangerous, predator-rich forest floor to scavenge. In this calorie-starved landscape, finding food was a matter of life and death. Fruit that had fallen from the canopy was often bruised, splitting open, and covered in naturally occurring yeast. This microscopic yeast ate the fruit sugars and excreted ethanol. This was the birth of wild fermentation. Ethanol is highly volatile. It creates a distinct, pungent scent that travels easily on the wind. Our ancestors evolved to use the smell of alcohol as an invisible, life-saving beacon. If you could smell ethanol, you could find the overripe, sugar-dense, highly caloric fallen fruit. But there was a catch. To eat the calories, you had to ingest the poison. Imagine the late Miocene forest floor at dusk. The shadows are long, and the threat of large prehistoric predators is everywhere. The air is thick, humid, and laced with the sickly sweet, sharp tang of decay. A small band of early hominids, ribbed with hunger, follows this scent trail through the brush. Around 10 million years ago, a random genetic mutation occurred in our ancestral line. Genetic paleontology studies have revealed that the ADH4 enzyme mutated, making our ancestors 40 times more efficient at metabolizing ethanol than other mammals. This was our ancient superpower. We became the apes that could eat the rotting, fermented fruit without dying of alcohol poisoning or becoming too drunk to outrun a predator. The slight buzz we felt was a neurological reward. The brain released dopamine to say, "Remember this feeling and find it again." It just saved us from starving to death. The drunken monkey hypothesis suggests this adaptation saved our entire species. the hominids arrive at a rotting pile of fallen figs. The fruit is warm, bruised purple and brown, foaming slightly as yeast goes to war over the sugars. As they gorge themselves on the fermented flesh, a profound physiological shift occurs. The ethanol enters their bloodstream. Their heart rates steady. A warmth spreads through their chests. Living on the ancient savannah was a state of chronic, agonizing hypervigilance. The stress of constant survival was mentally corrosive. The ingestion of this low-alcohol fruit offered something unprecedented. It provided a chemical easing of the primal panic. As the ethanol acted as a central nervous system depressant, the strict, terrifying hierarchy of the troop relaxed. Inhibitions lowered, endorphins flooded their systems. Eye contact became less threatening, and grooming became more pleasurable. Around the safety of an early fire, this minor intoxication became the glue of proto-social rituals. It facilitated bonding, trust, and vocalization. The extreme evolutionary risk of being slightly clumsy on a dangerous savanna was violently outweighed by two things: the massive calorie intake and the forging of deep tribal social bonds that ensured the group fought for one another. Evolutionary psychologists note that moderate alcohol consumption triggers the endorphin system, fundamentally enabling humans to form larger, more cohesive social networks. It lowers the barrier to trust, which was vital for tribal expansion. Some scholars even argue that alcohol was not merely an evolutionary accident, but a crucial cultural technology. By quieting the prefrontal cortex, the center of rational, selfish calculation, alcohol allowed hyper-intelligent, suspicious primates to trust one another enough to build civilization. It is a deep-seated trait. Even the tiny pen-tailed tree shrew routinely consumes naturally fermenting nectar in the wild without getting sick. The primate olfactory system is uniquely tuned to the chemical signatures of ripening and early decay, specifically ethanol and acetic acid. We evolved specific biological hardware to sniff out fermentation in thick forests. This drive is so deeply embedded that the moment humans settled into agriculture, our first priority, alongside food, was recreating the ancient magic of fermentation. Biomolecular archaeological evidence from Jiahu, China, reveals that as early as 7000 BC, humans were purposely fermenting rice, honey, and fruit. We took an accidental survival trait from the ancient forest floor and engineered it into a permanent fixture of our daily lives. Our ancient relationship with fermentation even shaped our internal biology. The ingestion of yeast and fermented foods deeply altered the human gut microbiome. The microbes ingested from rotting fruit helped our ancestors digest complex carbohydrates. Fermentation was not just a luxury, it was a symbiotic nutritional necessity. But the tragic friction of the modern era is that we have broken the evolutionary contract. For millions of years, ethanol was packaged in a strict, self-limiting ratio. To get a tiny buzz, an early human had to chew through pounds of fibrous, filling fruit. The physical fullness of the stomach acted as an absolute biological stop switch. Furthermore, the maximum alcohol content found in wild nature tops out around 5 to 8%. But then came the modern era and the invention of distillation. We figured out how to divorce the ethanol from the fibre, the nutrition, and the calories. We concentrated it into 40, 60, or even 80% pure liquid neurotoxin. Today, when a human walks into a bar and takes a shot of liquor, they are initiating a catastrophic neurochemical misunderstanding. The ancient Pleistocene centre of the brain registers the massive influx of ethanol and essentially screams in triumph. The brain believes we have just found the greatest, most calorie-dense fruit motherlode in the history of our species. It thinks we are going to survive the winter. It rewards this behaviour immediately. The mesolimbic dopamine system, our ancient reward pathway, floods the brain with a chemical high, cementing the behavior into our survival circuitry. But there are no calories to sustain us. There is no fiber. There is only a concentrated poison. The biological toll is devastating. Because our brains view ethanol not as a drug, but as a primary survival mechanism like water or food, the brain will literally restructure its own neuroplasticity to prioritize acquiring it. This neurobiological hijack is the dark heart of addiction. Chronic use shifts the brain from positive reinforcement, seeking the calorie high, to negative reinforcement. We begin drinking just to stave off the dark, anxious baseline of modern withdrawal. The modern alcoholic is not morally weak. They are the victim of a spectacularly successful survival mechanism working flawlessly in the wrong millennium. The very mutation that allowed our ancestors to walk out of the dying forests and survive a starving world is now killing us from the inside out. We are captive to an ancient code that refuses to update. Every hangover, every trembling hand of withdrawal, every cirrhosis diagnosis is the heavy toll we pay for a genetic hack that saved our ancestors from starving to death in a drying world. We survived the ancient savannah, but we brought the ghosts of our hunger with us into the modern world. We are left desperately drinking poison to satisfy an evolutionary craving that can never be filled.